Hey, welcome to The Explainer. Today we are diving deep into something pretty huge in the Delphi world. Embarcadero's new RAD Studio 13, codenamed Florence, is making a really bold claim that it can finally, once and for all, end the trade-off between performance and efficiency that's been a thorn in the side of cross-platform developers for, well, forever. Let's see how they're pulling it off. For years, developers have been stuck between a rock and a hard place. Do you go through the pain of building a separate native app for every single platform just to get that buttery, smooth performance? Or do you use a single code base, save a ton of time and money, but always have that nagging feeling that you're sacrificing responsiveness? That's been the fundamental compromise. And this is the enemy. UI jank. It's the official term for that horrible stutter, that little lag, that half-second freeze that just makes an otherwise brilliant app feel cheap, or worse, broken. It's the ghost in the machine that really separates a truly professional piece of software from an amateur one. So the big question is, how exactly is RAD Studio 13 planning to get rid of it? So first, let's really frame the problem that Florence is built to solve. This release isn't about just tacking on a few new features. Nope. This is about re-engineering the very core of the FireMonkey framework, all for the sake of pure, unadulterated performance. This quote from a deep dive performance analysis says it all. This isn't just marketing fluff. Embarcadero is explicitly targeting and declaring war on lag. The promise here is to finally let developers have their cake and eat it too, deliver true native speed, but from a single elegant codebase. All right, so how do they do it? What's the secret sauce? Well, the first part of the strategy is a massive ground-up overhaul of the entire visual pipeline. The whole assembly line that takes your code and turns it into the pixels a user actually sees on their screen. And here's the thing, it's not just one magic bullet. It's a carefully engineered 1-2 punch. It's a combination of two really powerful technologies that work together in perfect harmony. Think of it like this. One of them makes the process of drawing things on screen incredibly fast, and the other one makes sure that the drawing happens at the perfect moment. The result? Flawlessly smooth visuals. So let's break this down. First up, you've got the Skia graphics engine. Now, this is the raw horsepower. It's an open-source library, actually from Google, that takes all the heavy lifting of drawing 2D graphics and offloads it from the CPU directly to the device's GPU. That's what it's built for, and that's where that massive performance boost comes from. But like I said, speed alone isn't enough. That's where the display link service comes in. It acts like a conductor for an orchestra, synchronizing every single frame your app draws with the screen's actual physical refresh rate, a process you might know as VSync. By timing it perfectly, it guarantees that a new frame is ready the exact moment the screen needs one, which completely kills those dropped frames that our eyes see as jank. One provides the power, the other provides the perfect timing. And yeah, you're seeing that number right. 50%. We're talking about a potential 50% jump in raw graphics performance. And honestly, the best part? Developers can get this boost by adding just one single line of code. That's it. This is a massive game changer, especially for visually rich UIs on mobile devices, where every single millisecond counts. Okay, but what good is a beautiful, lightning-fast UI if the application's brain freezes up? A user isn't going to care about your slick 60 frames per second animations if the whole app locks up the moment they click a button to, say, download a file. And that brings us to the second and arguably more critical part of this revolution, unleashing the power of the parallel core. This slide right here illustrates the absolute most critical difference between an app that feels amateur and one that feels professional and powerful. See, in the old single-threaded world, the same exact thread that's drawing your UI and listening for your clicks is also responsible for doing all the heavy lifting, like querying a database, parsing a huge JSON file, or hitting a slow web API. So if that network request takes 5 seconds to respond, guess what? Your UI is frozen solid for 5 seconds. The user is sitting there, tapping the screen, getting more and more frustrated, and probably thinking your app is crashed. But with multi-threaded logic, you push all that heavy work onto a background thread, which leaves your main UI thread completely free to do what it does best, stay 100% responsive to the user. And this is the magic wand that makes it all possible, the Parallel Programming Library, or PPL. Now, for anyone who's ever tried to code threads by hand, you know it can be an absolute nightmare. It's like juggling chainsaws. You have to manually create and destroy threads and worry about terrifying things like deadlocks and race conditions. The PPL brilliantly abstracts all of that complexity and danger away. Using simple but powerful tools like T-Task and T-Threadpool, a developer can simply say, hey, run this heavy piece of code in the background for me, and the library handles all the messy, complicated, and dangerous parts for you. It is the key to keeping the application's brain working without freezing its face. This simple four-step process is really the secret to a perfectly responsive application. Let's walk through the life of a single background job, what Delphi calls a T-task. Step 1 is dispatch. Your main UI thread creates a task. Let's say, go fetch this data from the server, and it hands it off to something called the thread pool. The most important part here is that the UI thread does not wait. It immediately goes back to its job of keeping the app smooth. Step 2, execute. A completely separate worker thread from the pool picks up that task and does the heavy lifting. The user, meanwhile, is still scrolling, tapping buttons, totally unaware that this hard work is happening behind the scenes. Step 3, notify. Once the work is done, the worker thread can't just barge in and update the UI itself. That's a huge no-no in modern development and can cause crashes. Instead, it safely signals the main thread, saying, hey, I'm done and here's your result. Finally, step 4, update. The main UI thread, and only the main UI thread, takes that result and safely updates the screen. This clean, elegant dance is what creates a truly seamless user experience. And with RAD Studio 13, this whole system gets even smarter. The biggest new feature is this property that prevents a really nasty problem called thread starvation. Okay, imagine you have a thread pool with, say, 10 worker threads. What happens if all 10 of them get stuck waiting on a slow network call or a database query? Well, your entire background processing system grinds to a halt. No new tasks can run, the app is starved. This new property is incredible. It allows the pool to intelligently detect this situation and temporarily create new threads to handle incoming work, making sure your app never gets blocked. It's a huge deal for building robust, resilient applications. On top of that, new events like on-thread start and on-thread terminate give developers fine-grained control to set up things like database connections when a thread starts and tear them down cleanly when it's done. It's all about more power and more control. So, we've established that the final app runs fast for the user. That's fantastic. But what about us, the developers? Performance isn't just about the end product, it's also about how quickly and efficiently we can build, test, and debug that application in the first place. Our time is valuable too. And this is a foundational change. The RAD Studio IDE itself, the tool we developers live and breathe in all day, is now a full 64-bit application. This might sound like a minor technical detail, but the impact is absolutely profound. It means the IDE can finally break free from that old 3 to 4 gigabyte memory limit of 32-bit apps and use basically as much system RAM as it needs. Before, it was like working in a tiny workshop. Now, it's like moving into a massive warehouse. Look, if you've ever worked on a truly massive project, you know the pain of seeing that dreaded out-of-memory error crash your IDE. Well, the new 64-bit architecture essentially makes that a thing of the past. The IDE can now handle gigantic projects without even breaking a sweat. And that translates to tangible benefits for us. Faster code completion, faster code navigation, and less time just staring at the screen waiting for the debugger to connect. It all adds up to one crucial thing. We spend less time fighting with our tools and more time actually building amazing applications. So what happens? What happens when you combine this revolutionary GPU-accelerated rendering engine with a powerful, intelligent, and easy-to-use parallel core, all while working inside a more robust and responsive development environment? Well, you get the end of the compromise. And this quote right here, this gets to the absolute heart of it. The holy grail for developers has always been to write our code once and have it look, feel, and perform perfectly native everywhere. On Windows, on macOS, on Android, on iOS. The deep architectural changes in Flutter mean this is no longer some far-off dream. It's becoming a genuine, achievable reality. So let's recap the secret sauce, right? These are the pillars that hold up that big promise of no-compromise performance. It's a complete, end-to-end solution. It starts with a rock-solid 64-bit IDE for us, the developers. It powers the visual layer with Skia for raw GPU speed and the display link service for perfect timing. It keeps the application logic responsive with the amazing parallel programming library. And it makes sure everything shines on the target devices with platform-specific optimizations. All of these pillars work together to solve the performance equation, making apps built with the new FireMonkey truly fast, fluid, and powerful. And really, that's the ultimate takeaway here. This release isn't just another technical update, it's a fundamental shift in what's possible. It challenges that old, tired assumption that you have to choose between broad reach and top-tier performance. So it leaves us with one big, exciting question. If you could finally build one ambitious application that runs everywhere at true native speed, what would you build? Thanks for joining us on The Explainer.